Oh, no. Am I live? Is it working now? BS tells me I'm live, which says I don't. I am. Okay. Hello. Oh God. I spent the last hour trying to fix my stream because I couldn't stream. But it seems to work. Am I live? Wait, let me refresh. My bitrate is unstable, but... Okay. Hello. Welcome. I'm streaming again. I wasn't streaming for quite some time. Because first I got sick, and then I had to do other stuff. But yeah, let's start where we left off last time. And I didn't know where, but I find out. Seems to work. Yeah. Okay. So, OS dev. We are still at the bootloader. But my plan is to actually get to C code and in the kernel today. I swear. Promise. I know, as I said, it's like every stream that today we get into C code and in the kernel, but today is the day. I'm sure. So, okay, where were we? Let me get into NeoVim. Let me open my setup. I like it. We were at stage 2 and we successfully went into long mode. Oops. How it seems. Yeah, I remember. We were into long mode. Okay, that's good. And we set up paging 1 gigabyte. Oops. Okay. That means, what do we have to do to get into C code? I made a beautiful to-do because I know I would forget. Remake the pick. Okay. Let's say move the kernel up to this. Okay. Okay, seems easy enough. Should be doable. I'm just... I didn't do OS dev or any programming for like 1.5 months. Since the last time I streamed. And you know how it is, you forget everything. Why is this here... Why is this here hex and this here binary? Does this have I remember we were struggling last time with our paging, and I changed this binary, I guess. Let's just change it back to hex. Then I'm happy. And I got a build. Yeah, I created a build script. Or did I just... No, I have it. I have a build script which exports the cross compiler. Beautiful. And it calls make. Cause nah, wait. Let me get my setup right. Otherwise I can't work. Okay. Because I should have a cross compiler in opt. Oh. Yes, I have two cross and cross 64. What is in cross? Yeah, what is in cross 64? Oh. Oh, that means my script is wrong. Good thing I noted this now. I swear to God, I would have searched myself to death later. Good. Exactly. I have a cross compiler. It should work. And now we can build with a build script. Let's just test if we can boot. If everything still works. Okay. We are in long mode because of this beautiful red L. Okay. Seems to work. What am I doing here? Why is this? You should not be here, right? Okay. Anyway. Anyway. I would like to clear the screen actually. I don't need to clear the screen, it's... Who cares? I mean, when we are in the kernel will clear the screen anyway. I'm a little bit lost right now. Wait, shouldn't you... Okay. Let's do something productive. Reset up the pick. Okay. The programmable interrupt. I will have a typo here. Interrupt. And then we have to move the kernel. Because we load the kernel... Sorry, I'm not prepared at all. I didn't know what I did. We have extended reads. Oh, go back up. There. And we load the kernel with the pack. Ah, right, with the package. I forgot. And the package is... Ah, yeah, it gets shifted. Okay, so pick. Let me open my documentation first. Because remapping the pick should be fairly straightforward. We just need to send 4 init commands, and then we should never touch it again. So what do we have to... Can we set up the pick in long mode? I guess, right? Or can we only set this up? Why shouldn't we set it up in long mode? Okay, so for the pick he needs 4 init commands. First of all, what is the pick? The pick is actually really cool. It's a chip on the motherboard that it's a chip on the motherboard that handles hardware interrupts. So when we, for example, press a key on the keyboard, the pick will send an interrupt to the CPU, and the CPU will catch it. Hopefully, if you have interrupt enables. And for this, we need to set up the pick because we need to tell him at which interrupt vector to start sending. Yeah, I will explain as we go. So let's send the first init command from I should only 4 8-bit commands. Yes. Okay. So we clear EAX, and then we what I can actually show you. I'll show you later. Let me just first do. I can do and explain at the same time. But we need, what do we need? What do we need? We need okay. We don't need bit 7, 6, and 5. Bit 4 is 1 because this is the first init command. Don't need. Right? So we basically yes. So these 3 bits are not needed in the first init command. Yeah, fuck it, you can read it, right? Here for you. What am I searching? Search. But here. This is we are sending init command 1, and this is the structure. So we basically set bit 4 to 1, because 4 means this is the first init command, and we set bit 0 to 1 because we want to have I see this one, the fourth. Let's just document it. What is the we need the address command, master command 20. Okay. Okay. Oh, we also need to send it to the slave, I think. Okay. Now we do the second one, and the second one was specify the starting int or vector number for the first IRQ. Okay. Okay. So the IRQ, the p pick. Gosh, this is all. My memory is long gone. I have done it at some point, but I forgot it everything. So the CPU uses interrupt vector 0 to 31 for I now got a stress ball, so I can think better. Where was I? The CPU uses interrupt 0, 41 for its exceptions. So the pick needs to start sending at interrupt 32. Yes. So we are going to write 32 and send it to the data register of the master. Right? So, and if the master sends these interrupts, then the slave begins to send interrupt at 40, right? Right? Well, I hope. If yeah, it should work. Okay. And then we have only need if we have button. I think it can be ignored because it is set by default to IRQ. Huh. Well, I just believe my own documentation and ignore this one. Then we send this one. And there we only need to set bit 0 to 1. Okay. We ignore cause my documentation said so. Guess it worked. And then we move into oh wait, this one is binary. Oops. And we move into AR1. What did my documentation say? Data register. Then we send it to the data register. Okay. What is... I don't need this line. Let's set up the pick here. And move this one down here. So, let's compile it and see what happens. We clean it, we build it, and we boot it. Okay, so I think even if we did something horrible wrong here in the pick setup, it should not crash because if we set up the pick wrong, it should not crash the CPU. So we will find out later when we actually try to work with this chip, if we set it up correctly. But I mean, I guess. Don't know. Why not? I just wonder this here. I don't trust this one, to be honest. Because I write in the documentation, I think this can be ignored. This is not a sentence you want to hear in documentation. But fuck it. I ignored. Because my documentation think it can be ignored, so. We move the kernel. This should be fairly straightforward. And if we move the kernel, we actually have done everything. We finally can start writing our kernel. Oh, we are too long on this bootloader. So, we move the kernel. How was the instruction called? Move S. Okay, easy. So we put in the RSI our kernel is there, and we want to move our kernel. So the destination will be this one. Because because we want to go up to the extended memory. Oops. This is right? 1, 2, 3, 5. Yes, I don't have my glasses on. Because yeah, fuck the lower memory. Because we only have 640 kilobyte of low memory. So if our kernel ever goes over it, we're going to have a problem. I mean, I don't see this happening soon, but it's just, I mean, on modern system, I think we can live with it that we ignore 640 kilobyte and just place our kernel at 1 megabyte up. So there is this instruction. I had it open somewhere. Move S and then the size, also move SQ. And this will move 8 bytes at a time from RSI to LDI and will increment it. So we need to repeat it. We need to repeat it. Yes. How big is our kernel? I think it was 100 sectors. Yes, 100. Because we also make 100 here. So that means 100 times 512 by 8. Wait, no, what did I do? What did I do? Leave me. 100 times 512. What was I in decimal? So we do it like this: 5100 times 8. So we know what we do. Where are my comments there? So 100 sector. So. Okay. Guess this should work. Try it and see if we are crashing. We aren't crashing. Okay. This should be it. This should be our bootloader. Okay. That means we can actually start on the kernel now and pretty soon on the C code. Of course, it's, I mean, it seems to work. Cool. That means we can create a new folder. I don't know how to do this. We create a folder for all the kernel stuff. And there, no, I don't want to rename it. We need a assembly file, cause. We can't just jump into C code. We jump from here, we jump into the kernel assembly, and from the kernel assembly we jump into the C code, because the kernel assembly will actually have the extern C function. This is how we are going to do it. And we can finally create a kernel.c file and a kernel.h file. Isn't this crazy? So firstly we make a header guard. Kernel, define kernel. Okay. Then let's just factory boot and you going over there. We have nothing to include our kernel.h, because we obviously don't have default libraries or anything like this. And we make void main or kernel main, which doesn't have any arguments. So the goal of today is we land into there. The goal of today is we land in our kernel main function. Let's just put it in the header because the assembly file will need it. It's void asset. Okay, now you are here. 1, 2, 3, 4, 5. Right? Yeah, 1 megabyte. You are no, wait, not bits. You are 64 bits, and you are here. This kernel RSM file need to do nothing. Except call main. Just hold here, I guess. Does this kernel file has to do anything? Just I'm pretty sure it has to do something at some point, but for now nothing. And you find the main file in an external header. Exactly here. Right? Yes. I hope. I'm just thinking. Yeah, okay. Fuck it. Let's put all of this into our makefile. You have a boot and then you have a kernel. So the kernel. How are we going to do this? The kernel, what are you going to do? We need what do we need? Holy shit, I forgot something. This is important. This is really important. Damn, this is really important. Yeah, fuck you. The kernel RSM file needs to be aligned to 512 byte. Because the C compiler, not to 512 byte, but it needs to be aligned to byte because the C compiler aligns all of its shit. And because we put assembly into C, we cannot risk to get everything out of alignment. Yes, this is important. Holy shit. I'm writing, but not in my Vim. So just realign it to 512 byte because it would be more than enough. And no, I remember all of my shit. We need to make a linker script because we have C, and we need to put the all of our assembly. No, we don't need to put the kernel assembly in the custom section because this is where we align it. Yeah, no, okay, I was talking stupid. But later when we do some assembly, we need to put it in our own section for the linker because we don't want to align it all. And if we don't, either if we don't align it, or if we don't put it in our own section and let the binary file put the linker and the compiler put our assembly in the text section with the C code, we could get the C code out of alignment. And this is ugly. Alignment errors are the worst. I think I have talked about it in any of my streams. But alignment errors are hell. So this is what we need to keep in mind. But not for the kernel assembly file. Because I'm just thinking loud. Because the kernel assembly file needs to be at the start of our binary file. Yes. Because it's just a binary file. And when we are going to jump here to this. And when we do this, we basically jump into the first instruction of our kernel. And the first instruction of our kernel needs to be this assembly file. This is important. And this is why we need to put the kernel assembly as the first thing in the assembly in the kernel binary. And yeah. I'm talking too much. Let's just do it and try it and fail and try it again. Do we make it? But we need a few more files, so we just make a variable for this. Oh. So, the kernel assembly needs to be the first thing. That's important. Yeah. I don't autocomplete. And you are... We are just going to compile it. as a binary file. Right? Am I being stupid again? This should be it. This should totally be it. Let's just try it. Let's just build it. You didn't build kernel because we need the kernel up here, so. Dependency dropped. Did you mean you dropped extern? Because you didn't find it? This is okay. This is fine. Let's just go into bin. You don't have... Okay, wait. Let's just... As long as we don't have this. What do you mean with dependency dropped? What do you want from me? I do wrong. First of all, I want this. This is my naming convention normally. I just forget it. What is your problem? Hey, we have a kernel ASM. Wait. Why are we... I am confusion. You are not a bin file, by the way. Cool. You are not a bin file. You shouldn't even go into the... You need to go into the build directory, cause you are a fucking object file. Eh. Because we are going to link you later. Yeah, I'm stupid. We are going to link you later. So you are an object file. First, this one. Then we are going to do this. So let's try it one more time. We make clean. We build. Shit. Yeah, that's true. Because you are going to use the linker script, you don't have an org. This is totally right. Yeah, we make clean. Or we can make it. Okay, we have our kernel object file. Fuck. I don't know what. Oops. I don't know what you mean with dependency dropped. Circular. I don't know what you want from me. I'm honest. I don't know. Ah. Anyway. Now we need to compile the C code. And let's just, I think I didn't try my cross compiler. So let's just pray that my cross compiler works. Because otherwise I have a problem. We are also making the kernel.c.o file. Kernel.c.o. Let's just remove the C. We don't need it here. We know that when we have nothing, it's C, and when we have RSM, it's assembly. So, you are kernel.c. Okay. So, make with this beauty elf GTC. Right? This is the command. Okay, we need some compiler options. I have this somewhere in my documentation. I have here compile C. This is 32-bit, but here are all the flags we need. So we needed flags. We need this one. Yeah, freestanding makes sense. No standard lib. No default libs. No start files. No built-in. Then we have useful flags. Ah, this was the word I was searching for. With the we align our C code to a power of 2 boundary. And this is why we need to do this in our kernel assembly, because we can't place it in an extra section. My chocolate is empty. Shit. Okay, let's just do what my documentation suggests. I can't speak English words. Let's just have our flags variable. And let's just wait, let me open this on my second monitor. So I can put all the flags in. So we need freestanding, we need nor default, we need files, and we need so then we enable all compiler warnings, we turn optimization off, we enable debug, and we also say we are not allowed to have unused functions. So if we create a function in the kernel and don't use it, then we get an error. The compiler throws an error and not only a warning. This is for us, so that I know I probably forgot something because I created a function and didn't use it. And we also do this with our variable. Then we align everything. Give it caps lock here for a second. Align and align. So then we would, so I basically typed every flags, the needed one, the useful, and the alignment. Here have some optimization, but we don't do this right now. We do this later. Okay, let's go. Let's also make a include variable. And we are just going to include kernel so that we find everything. Okay, let's try the cross compiler. I just hope so much that my cross compiler is working. Shit, because I never tried it, I'm afraid. Okay. We compile the kernel. We want to compile. Ah shit, we also need a linker script. I hate linker scripts. Because this is a fucking own language. It's fucking black magic. But anyway, we will bite through it. Okay. So we compile with our flags. We use the standard so that the compiler doesn't strange stuff. We also want our include, please. Oops. Include, please. And we want the our kernel.c file and put out I don't know, completely wrong. Object file. Right? Is this correct? Well, I guess. I'm afraid to try it. Okay, fuck it. We are going to build it. Okay. Did you mean W all? Yes. Smart compiler, you are smarter than me. I totally mean W all. Oops. And what was the second one? Did you mean align labels? Yes, I mean it. What did I align label? Oh, I write labless. Okay. I mean this, yes. But how do you write labels? Shit. Labels, yeah. How do you speak it, I guess? Labels. So. But the compiler seems to be alive. I mean, he told me what I do wrong. But I remember we need the -M64 flag. This is important. -M64. Not 63, please. Okay, let's try it again. Well, this we will fix later, but he fucking compiled it. Look at this. We have a working object file. Oh, yes. I think it's working, but we have a working compiler. That means the first compiler is working, and I am fucking glad about this. So, what was the problem? I ignored it. Two. The kernel. First of all, you have the start label, please. Also, I don't like that you are up here. Ah, fuck, I deleted it, I didn't yank it. Oh, I yanked it. What did I just do? So. 64, holy shit. Having a stroke here, so. Okay, now I'm just happy that it works. Make claim. Let's do it again because it built so fine on the first time. Let's just do it again. Bam. Okay. This is great. This is really great. Oops. That means we now need we need a linker script. We need a linker script, and then we can fucking link it to a binary file. Also we link our two not bin. We link our two kernel, the assembly and the object file into one kernel file. And this should do the job. So, linker script. Yeah. I'm hate linker script. But I have it in my documentation somewhere. Because I'm just going to copy what I have there, to be honest. Somewhere I have it. Yeah. Okay. So, we put the linker script in the source, I guess. Kernel link. Does the linker script have? Does a linker script normally has a file extension like yeah, LD. Kernel link.lb. Then oops. We are going to fill you. Okay. Entry. The entry point is start. And the output format is binary. Okay. Then we define the sections. I'm just going to Need to read it. So, first of all, you are placed at 1 megabyte. Then we align everything. We basically just align all our sections by 1 page. Oops. And in here goes text section. Who could have got that? Up, up, up. Then we have the section. And here goes the... Then we have the fucking data. And the BSS section. Here comes the BSS and stupid. The common one. Okay. Can we do comments in linker script? Write comments in linker script. Yes, because later we need a oops to do create a assembly section for our own assembly. Why I'm writing in caps. Sudo create a assembly section for our assembly code in the kernel so that it doesn't put all of our C code out of alignment. Because this is smiley looks like shit. Okay. So just I remember I need to do this. Is this linker script correct? Yes. Okay. So what we need to do now is we need to put our what we need to go away. We need to put our kernel or 2 object files in a single file, and then we are going to link this file together to a binary file. Okay, so we are here's the linker for this. So it's relocatable so that it doesn't link it to a file, and you are, how do we call it? Kernel. Okay, let's just try it. We change the name later to something better. That's right. cannot find. Oh, right. I'm a little bit. You are not. You are. You are. I need to use. I need to use the script files. Okay. Yeah. 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 Smart. I need to change this. And to build. So, yeah, now. Cannot use executable file. Kernel.org. Well, this is called. Why executable? Why? What is your problem? Let's just change nothing and run it again. Okay, also cannot use executable file. Why executable? I thought. Oh, this this is why it's green. I was wondering why are you producing an executable? You stupid. Why are you producing an executable? You shit. How do I tell? Okay. How do I tell? It's not because of you, right? Yeah, okay. Then I need you back, please. Why? Why? Why are you making an executable? With the last cross compiler I worked, he didn't make an executable with the exact same. Oh, wait. Did I forgot this? No. This is nothing. Why are you making executable? I've never worked with this cross compiler before. How do I tell? How do I tell this compiler it should fuck itself and don't make a executable? Okay. You should make an object file. Fuck. Okay, let me Google. Ah. Internet tells me MX. Ah, okay. Shit. How do we tell the compiler to not make a executable, please? Did I forget some? Did I forget? Uh, sh mm, because I mean, I can show you guys. I was working with the i686 cross compiler, and he didn't make an executable with the exact same commands. So I was hoping that this cross compiler also wouldn't. But I guess that's why I should have tried it before. Shit. I bet that's just one. That's just one command I don't know right now. Why are you creating an object file? You're not even linked. Why are you creating an executable file? I have questions. I really have. The compiler always creates object files. I just read it. So why are you... Why? Cannot use executable file as input to a link. Why are you an executable file? What is your problem? Ah, God. Eh. Are you really an elf file? Wait. How do we dump our object file? Ah, what? Let's just test something. Kernel ASM. Oh, you are L32. You are L32. Shh. How do I tell NASM to compile to 64-bit? NASM adding bits to the top of the assembly source file. The trick. Hmm. Oh. I can just do ELF64. Wait. Cool, I guess this worked. Okay. So, great that we find this out. Now back to our other problem. Our linker. Our linker tells me cannot use executable file. And I am wondering why the fuck are you an executable file? Why? Just remember that I've flagged it. Also seems to be useful. Okay. Okay. So, executable, huh? Why? What? Why? Why are you an executable? I thought the compiler always create object files till they are not linked. So does the compiler automatically link it randomly with some default stuff? Can I do? Don't know what I'm doing. Why? Why? Ah, why? Cannot use executable. Okay. This error usually means you're missing a -c when compiling a simple program. What? You know what? Let's just trust this random stranger on the internet and add a random C. Why? What is the C flag doing? Let me Google it. GTC flags. What? Why? I have questions. And I have fucking 300 matches on my match case. Match words, okay. Leave me alone. What is the C flag doing? I mean, okay, cool. I guess I could have figured this out if I'm not a noob. Because I only ever used the... This is fucking scuffed, okay? Look, I only ever used this compiler, okay? This one. And this one didn't need the -c flag. C flag. Okay, anyway, we fixed it. Move on, I guess. Great. We just remember this, I guess. So let's just see. Did you create it or the full kernel? You need to name it differently. We need to name it differently. We name it. We name it. Kernel. We name this one kernel, and this one kernel entry. No, this one. Doch, yes, this one kernel entry, and we name this one kernel main. Nah, kernel main is... No. We keep the name as kernel, and we name this one kernel full as well. What are you doing? We build it. And now our error, or kernel RSM error this gun that I already forgot what the error was, but that it inline something. Don't care, it's gone. Fuck it. I want to try something. No, I don't want to try something. I want to try something. If I have an unused function, then the compiler should tell me that I'm stupid because we set it in the flags. Right? What? Or does this happen at a later stage? Maybe it happened, maybe it's going to happen at the actual stage when we make the binary file with the linker. Let's just try it. Because we now have the full object file. Nah, it shouldn't happen at this stage. I mean, we already have the file. No unused functions. Hmm. Maybe it does. Yeah. It makes sense that it happened at this stage because other files could use it. You know what I mean? Ah, right. Yeah, it makes sense that it firstly happened at this stage because other files could still use it. We need the linker script. How do we call the linker? How do we call the linker script? Kernel linker. Kernel linker.ld. You are going to use the build and the kernel full, and please produce a beautiful bin file, a kernel bin. Right? The other way make clean. We build it. Make file returned error. Source, yeah, nee. Kernel linker.ld, no such file or directory. We called it kernel link, not linker. But again. Error 1, syntax error. Okay, source kernel link syntax error. Okay. Fucking syntax error in the linker script. What is your problem? Oops. Did I need comma? Did I need this? Wait, let me. Linking the kernel. I forgot I semicolon. So. You are creating a binary file. I mean, normally it is a good thing But the compiler should actually cry, because we have an unused function here. This is not a good sign. This motherfucker is just going at it. Why? What? Oh. That's not built. Bin. Moin. Kernel, danke, thank you. So. Oh, did it strip the function? No, it shouldn't. My PC is lagging. Can I please make you larger? Why is my PC dying? Oh gosh. Okay. So. Hello. Okay. So this here is the assembly. Why is my fucking PC dying? So this here is our assembly. And this here is our C code. I don't trust it. We don't have any sections, and the sections are not aligned to 4069 byte. But you should be. You know what? We are going to try it. How do we call it? Kernel.bin. So, why not just try it? Before we try it, we halt here because I want to see if we did this here correctly. If we did the relocation correctly. So we're going to drive up the debugger. Let's just put it. It's not crashing. Are we even jumping? We are jumping. That means that we should be here. This looks good. This looks promising. Why is my PC dying? Holy shit. This looks promising. Let's just check it. I didn't have to actually add it, but fuck it. Not QMX. Is this the right one? So, we Pending. Fuck. We drive. And now we hold. Now we hold. Yes. Okay, look at this. We are in our start function. And we jump to the start function. This looks very promising. This looks really promising because later we are going to call Carmain. And it's exactly 1 megabyte and 512 byte in. Guys, this is looking really good. How the fuck did you get in here? Okay. Didn't I just close you? So, and now, you know what? We are going to investigate this later. Fuck it. And now, if our everything worked and our cross compiler worked, we successfully jumped to C code. Wouldn't this be fucking great? Okay, guys, let's go. Let's try it. Okay, it's looking good, looking good. It's looking really good. This time we need the symbol file. Packet. I developed a 32-bit operating system before. This is why I have this fucking shit in my fucking muscle memory. But we are on 64-bit now. How was it called? 68, 64. Could have figured this out myself. You know what? We are actually going to break at kernel main. Oh, it hit a breakpoint. I didn't want to. It hit the fucking breakpoint. But this is. I mean. This assembly looks very promising. It's working, I guess it's working. Let's just step over it. And we are. Oh. We are in it. We are in C code. Holy shit. Why can you please stop dying? I know you are paused. Fuck you. Yeah. Leave me alone. We are in C code. Okay. So. This is fucking great. So we actually went from our first bootloader to our stage 2, and now to our kernel, and then to C code. Let's just do something, I guess. Let's just see if it's really working. I don't trust this. And then we are going to look into why my arrows are not working. We make coin. We build it. What was that? Warning, unused variable. I can't say this. Why are you a warning? You should be a fucking. Here, look at this. You should be an error and not just. Did I forget? You should be an error, not a warning. Ah, wait. Did I forget the thing that errors turn into warnings? Oh. I did. Look at this. So. Aha. Okay. Now we got the. I'm just going to use you quickly. And now this should also work. Unused function. You should also return. You should also return an error now. Why are you building? Why? Is it because... Hello? Compiler? Compiler, hello, I clearly have an unused function here. Hello? I also need to configure my NeoVim that it doesn't do all the STD and... Alright, I can do this very quick. I have this somewhere here. Copy. So, now, now my NeoVim, if I restart it, I'm recording. Now my NeoVim should actually be aware of all the compiler flags, right? So you shouldn't why I'm doing namespace, this is a C++ thing. You still have all these functions. Do I need to make neovim? Not important. I do this off stream. The next stream, our neovim and our intelligence will actually know our flags. So neovim, the intelligence in neovim don't, give me all these standard functions, and also it can should turn this shit red, cause this is an unused function. But the compiler should also do this. So why aren't you doing it? Did we even have it here? No unused functions. Anyway, I actually wait. Let's do one thing after another. I just wanted to look at the I firstly wanted to look at this here. So we stop at kernel.h kernel.c 14. We break at kernel.c 14. Then Fuck. Ending. So if we now print A 5, print B 10. Okay. Cool, this is working. I just wasn't sure. And I learned something cool. We can actually set this assembly flavor to Intel. If I would write it right, set these assembly flavor Intel. So if I now step one time, it is Intel. Okay. Actually, good to know. Okay. We continue, and we hit the. Oh, okay. We continue. We close you. We close you. We exit you. We fuck you. Okay. So everything is working. We are in C code. So the last thing. The last thing is why aren't you crying about this unused function? This is clearly an unused function. Am I stupid? Does the kernel use help? And I just don't know. No. No unused function. Fuck. No, bash. Why I'm some other bash? Can you go? No unused functions. So, where is the problem with this? Why I clearly tell the compiler it's not allowed? But the kernel just doesn't. Yeah. The kernel, the compiler just doesn't care. Yeah, this is a minor error. We will look into it. We will look into it. I will look into it. Not we. I will look into it off stream when I fix my NeoVim. Aber let's make something cool. Let's make a function that clears the terminal for us. It's 2 byte. One character is 1 byte, and for and background caller 4 byte, 2 byte. One shit is 2 bytes. We use here 16. No. Don't do this. I can use this one, right? I can exactly use these two. Yeah, I mean you in 16T. The fuck did I do? Don't need you. And I put you in the header file because I like this. Fuck are you? I copied you. Include. So. Unused variable video memory. Hey, our my say it. NeoVim is aware of my compiler setup. Cool. So now I know I need to look up in the internet. By the way, this is just temporary for now because we can finally have fun in C code. Of course, the next few thing we create a real terminal class and stuff, and you come in a file that handles this. We just write it dirty like this for now. How many rows and columns do we have? Nicht Video Mode. Text Mode. How big are you? 80 character. VGA mode 3 provides a text interface. So 18 times 5, 80 times 25. Calculator. 80 times 20. 80 times 5. 2,000. Okay. And we are just going to write nothing into it. Okay. Cool. We cleared the screen. I mean, we can actually give it a cool color if we want. Let me just... Yes, it. What is color? What is text? What is color? What is text? I need to know. Yeah, back color, fore color. We don't care. Each character takes up space in memory. The first byte is split into 2 segments, the fore color and the background color. The second byte is a 8-bit ASCII. Okay, first byte, 2 segments, fore and back. So that means we can... Can you stop this shit? Something is wrong with my thing. That means we are going to... What color do we want? Let's just make it magenta. 5. We are going to write uh, 5 and shift it by 4. So I never know the order of the shift operator. So if I do 5 and shift it by 4, it should be... I did it again the wrong way around. That means this one is the correct one, right? Yeah. So. Why are you not a beautiful color? Hello? You are video memory. You are in... I am in VGA mode 3, right? Am I in VGA mode 3? Right? Or am I I mean, it should be in default for VR Mode 3. We still have time, right? Space. Change. Purge. We should be in VGA mode. Where is your... I'm struggling at a simple shit. I'm really struggling right now. I'm honest. Hey, am I stupid? Okay, wait. We learned. Each character takes up 2 space in memory. The first byte is split into two segments, forward and back. The first byte. So, and here we get the first byte. These 4 are for the back color. These 3. This one is for the bright. So, if I take 5, we do it slowly. If I take 5 and shift it 4 bytes, we are here. We have 4 written here. Yes. So, wow. Wow. Uh, I'm struggling. Why I'm struggling here? This is not good. Guys. Do I call the function? Yes, I call it. I mean, yeah, okay. Hello? Can you please not? So, oops. So the last 2 bytes are color, or what? The last are color. Did I read it wrong? Each character takes up 2 spice memory. The first byte is split into 2 segments, 4 color background. The first byte. I mean, the first byte in my mind is this one. And not this one. Oh, I mean, I take it. At least I know that I'm not completely stupid and completely fucked up the most basic thing, but okay. Okay, we got it. Okay, so we actually did it. I called since 3 streams that I led into C code, and now we finally did it. Okay. Yeah. Great. So now we can fucking leave assembly behind for most and can do stuff in C. Wait. Oh, there was something I wanted to do. Are we going to do this today? I mean, it shouldn't take long. Because we could map our kernel directly to the high kernel. Where do I do? You know what? Let's do this real quick. Let's try it. I want to do this fast. Fast. High kernel. What was the high kernel? Fuck. Can't write anymore. I just want the address of the high kernel, please. Is it called high kernel? Yeah, okay. We can define it ourselves. Let's just map a high kernel. What is suitable as a high kernel? I like this. I think this was the high kernel on my other project. I can't remember, but I have this in mind. or higher half kernel, however you call it. So I just looking up. We need the index. Need the index, please, of the PLM4. So we are going to shift it 39 bytes. Division by 0 is undefined. Wait, thanks. What? Did I mess up the shift operator again? Hello? Hello? In. Ah, okay. 15. 9. How large are you? You are how large? What is 47 minus 39? 6. Oh no, don't. 8. Just forget it. And we only need 8-bit. We need 8-bit. We need 8-bit. We only need 8-bit. Wait, I'm stupid. We need it. Could have figured this out myself. We are going to do it and I did something wrong. Please, I just want to calculate the index. So again, F. 9. Then we just need 9-bit, so we give you on 65. Would have figured this out. So that means if we write can we write the same address? Can we do the same page table? I mean, I guess. We want to do the exact same. And now we should be able to jump at F plus Bro, my brain is fried for today. Yeah, shit. How many zeros? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. And we land at the exact same address. Ta-da! Now we jump to this address and actually land, thanks to paging, at this one. That means, give me this address, please. I mean, I'm not going to keep it, I'm going to do it right the next time. I just actually wanted to try. But now we can actually compile it to this address. Bam, 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 and it works. Cool. I fucking love paging. Anyway, this was just wanted to try. We do this right in C code anyway. But by the way, if anyone wonders how I got the index, of course you can always ask in chat because I don't explain very much. So if any question is, just ask anything. But how I landed at this index is I open my documentation. Here. This page table is the PLM4 table. So that means why that means it's my mouse fucking. That means, my god, don't give up on me, GUI, please. Yeah. That means if we have an address, like we say this should be our high kernel. And we want to map this address to 0, basically. So if we, do I have a text editor? Basically. No. Go back. My god. Basically, if we... Is this right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, yes. Basically, if we enter this address, then we actually land here. And if we jump to this address, we land here. This is this is why we can jump to this address, but still came out here. This is not the explanation why, but this is what we are doing. And the why is because I explained it in the other stream in C code, but I wanted to show how I got there. Yeah. We want to fit it into the PLM4 table, which is this one. The PLM4 address starts at 39 byte. So we, oh no, I deleted it. We shift it 39. We can just do it at once. So we do it this. So. And now this address, PLM4, this PLM4 part of the address is 9 byte long, not 6. I calculated. It's 8 byte long. Holy shit. So we end it with 8 bytes. Up. This is the index. Did I do something horrible wrong again? No, we not ended with 8 bytes. Yes, we ended with 8 bytes, but I went too far. Holy shit. Okay, wait, look at this. We shift it. Oh, please. Can show the decimal. Hexadecimal. Please put it into decimal. Thank you. We shift it 39 byte. Bam, bam, bam. Why can't you do this? We go back to hexadecimal. We shifted 15. We shifted 15. We shifted 9. I feel like I'm fucking stupid. Yeah, 15 is F. We shifted F, we shifted F, we shifted 9. Holy shit. So we ended with 8. Shit. This is not going well. This is not going well. We ended with 9. Holy shit. I want shit. We ended with 9. Are you fucking kidding me? My brain is so fried. We don't end it with 8. We need to take 9 bytes. Oh god. So we ended with this. And get 100. Yeah, it's time to end the stream. I'm honest with you guys, I'm fried for today. I'm fucking fried. Anyway, I said in the last stream, I explain paging when we are in C code, because in C code with an actual debugger you can actually explain all of this, and this is why I didn't explain it in assembly. I just wanted to play around with it. And map a high kernel. I mean, we delete it anyway later. Anyway, I'm going to end the stream now because I'm fucking fried. I am fucking fried. But yeah, we did it. We are in C code. And my mouse gave up on me. Hello? Oh, you are stuck in QE mode. We are in C code. Yeah. Okay. Just thinking, did I forget anything important? No, I didn't. I did say 8 bytes, right? No, 9 bytes. This is 9 bytes long. Obviously, this is why I also did. I said 8, but I did 9. 9 bytes, not 8. Anyway, I explain paging and everything in C code. Now that we are in C code, we can actually visualize it. Okay, cool. Then I'm going to end the stream for now. Have a good one. See you at the next stream. Or not. Yeah, have a good one.